Welcome to my YouTube channel. I'm going to show you how to plot a quadratic graph. So start with a simple equation y equal x squared. So when we draw this graph, we can draw like a simple parabola like this here, right? So using this we can transform into a normal quadratic function, just like y equals 2x squared, y equal half x squared. So we can see differences between those function with y equal x squared. Alright, so I'm gonna input x equal 1. So we get the value of y like 2 plus or minus 2, 2, y equals half. So according to this, when we add 1, the y equal 2x squared function, what's the value of y? It will be 2 here. So this is 1 for y equal x squared, right? 1 for y equal x squared, 1 for 2 for y equal 2x squared, that means here. So we can get a conclusion about how y equal 2x squared gonna be, right? When I draw this, it is just like that. Alright, you see that there is a shrink, no, than the y equal x squared. So when we add y equal half x squared, the value of y is half. This means it is like this, right? Expanding like this. So actually those type of graphs, we can only see the difference in comparison with the same type of graph. Alright, this is y equal 2x squared, this is y equal x squared, this is y equal half x squared. So now you see that differences between those two. So in other words, whatever value y equal x squared here, whatever value we input to the a, so we can get this type of equation. Minus value, we are talking about y equal minus x squared. This means every value here for y will be negative. That means here like this. I'm not going to explain y equal minus 2x squared, y equal minus half x squared, because those are the same like this. Alright, exact mirror image of this. Okay, let's go to the next step. How that y equal x squared plus 1 gonna be? So this is, we see that when we see the normal y equal x squared, so there is a 1 add for the this graph. That means whatever value we substitute for x, y will be the answer of y is one step ahead. That means y equal x squared plus 1 is shifting upwards because of plus 1. This is 0, this is plus 1. So when we use x squared minus 1, it should be like this. The turning point, that means this is the turning point, inflection point. In other words, minimum value. What is the minimum value? Minus 1. Here is like this. So there is a intersection of x. You see that when we substitute y equals 0, x equal plus or minus 1. Therefore, the intersection point will be plus 1 and minus 1. So vertical, this is just like vertical shift. Okay, so then we try x minus 1 square. This is we can assume like this. Let's take x minus 1 equal capital X. So the graph is y equal capital X squared. That means here y and capital X. So normal like this. But actually in real condition we want simple x. So when we subject simple x, so capital X plus 1, that means we have to add plus 1 for a x-axis. That means the simple x-axis will be shifting backwards, right? So the graph is horizontally shifted. This is y, and I add simple x. So horizontally shift. So that means the x value 0 must be here, but actually simple x minus 1 equals 0, x equal 1, right? So here is 1. This is the equation of symmetric. So we can use like this. The graph is shifted one block forward towards the positive values of x, right? So x equal 1 is equation of symmetry. Those are x equals 0, the equations of symmetry. So this is the equation of symmetry is changing like that. So when we use y equal x plus 1 squared, that means x plus 1 equals 0, x will be minus 1. That means minus 1 here. The equation of symmetric is here. So the graph is shifting horizontally backwards. This is y equal x plus 1 squared. This is y equal x minus 1 squared. Okay, like this. So normally using all these detail we can draw any quadratic graph. Okay, we will see some examples. So I'm gonna draw y equal x minus 1 squared plus 2. Okay, y equal x minus 1 squared plus 2. So we can use, this is y-axis, this is x-axis, 0. So here when we replace capital X here, what when x minus 1 equals 0, x equal 1. So equation of symmetry 1. So this is the line of symmetrical line. All right. So then this is the horizontal shift. Now we consider about vertical shift. You see, you know that I have given you previous examples how to shift vertically. So plus 2. This is the 2. This is the inflection point. The graph should be like this. Okay, this is the turning point, a minimum point. Okay, right. We can draw minus x plus 1 squared plus 4. So we know that equation of symmetry x plus 1 will be 0, x equal minus 1. This is a symmetrical line, and also there is a horizontal shift as well. Okay, so when we draw this here, x and y 0. So this is the minimum sign. Sign is minimum. That means this is a maximum, right? Maximum. And y equal minus 1. This is the equation of symmetric line. And also plus 4. Here, this is the plus 4, and here. So graph should be through this here, but we have to apply. We have to find the value of y when x equals 0. When x equals 0, what happens? Y equal 3, right? So this is 3. So graph should be like this. This is the intersection point of y with the graph. Okay, alright, we can find the value of x, intersection point of x when minus x plus 1 squared plus 4 equal 0. So here is x plus 1 squared equal 4. So x plus 1 equals plus or minus 2. There is 2 value, actually there is 2 intersection points and 2 values. When considering plus 2, here x equal 1. When considering minus 2, x equal minus 3. So here is x equal 1, x equal minus 3. This is the graph. So using this simple method, you can draw any type of quadratic graph. Very simple. Try to use this, and actually not only the quadratic function graphs, we can use any graphs using this type of techniques. you have to try to find horizontal shift, vertical shift, and what are the changes using very above techniques. Okay, this is enough, and see you next lesson soon. Thank you for watching my channel.